We're going to take a look at our counting principle and we're going to take a look at some probability today. So your counting principle says if you have an event M that can occur in M ways, followed by an event N that can occur in N ways, basically you just need to multiply how many ways the first thing could happen times the number of ways the second thing can happen. So as we look here, we have a family going on a trip. They could either go to the beach or to the mountains, and then they can try to figure out how they can get there, either by car, plane, or train. So how many different trips could they basically have? So they have two places they could go, beach or mountains, so we have two. And then they have three ways they could get there, car, plane, or train. So how many different possible options do we have? We have 2 times 3 or 6. Suppose we have a 4-digit code that we need to have to retrieve a message from our phone. So 4 digits, so I put down 4 spots here. How many digits are there to begin with for your first option? Well, there's 10 because there's 1 through 9 plus 0. Well, these digits could be pressed more than once, so for your second digit, there's still 10. And for your third digit, there's still 10. And for your fourth digit, there's still 10. And so then we get this. Now, if the digits would not be able to be repeated, then that would be different. We'd have a 10 here. If it couldn't be repeated, 1 would be used. There'd only be 9 options left over here. If 2 were used here, then there'd only be 8 options left over here, and so on. We'll be getting to that, but not right now. So here we're doing a 6-digit license plate, where the first 3 are letters, the last 3 are numbers. So I put down 6 spots for all of our options. And I would encourage you to do something like this. It'll make it a lot easier for you. So first 3 are letters. So how many letters are in the alphabet to choose from for the first one? Well, there's 26. The second one's also a letter. Well, there's still 26 letters. The third one is a letter, still 26 letters. The last 3 have to be numbers. Well, how many digits do we have to choose from? Well, there's 10 digits to choose from. There's still 10 digits to choose from for your second number here, and there's still 10 digits to choose from for your third and final number. So you just have to multiply all those together, and you get a relatively big number. So some things are dependent. So when we go back here and I gave you the option of 10, 9, 8, 7 because we couldn't repeat, that's considered a dependent event where the next thing's affected by the previous thing. So suppose we have a student who's planning to take 4 different classes. Well, how many options do they have for the first class? So I put down 4 options here. First class, there's 4 classes. They're already assigned to that one class. How many options are left? Well, there's only 3 left remaining to choose from, so there's only 3. 2 options have been used and selected here, so there's only 2 that have been selected out of 4, so there's only 2 options left. Now we've already selected 3 out of the 4, so there's only 1 option left here. 4 times 3 times 2 times 1 is also known as 4 factorial. And you multiply that out, you 12 times 2 times 1, and you get 24. Multiplying your probabilities. So if you want the probability of 2 things occurring, you can then just multiply those together. So here we have 9 dimes and 7 pennies. They're randomly selecting a dime, looking at it, and putting it back in. So we want to know what's the probability that they're both dimes. Well, we have 9 dimes out of a total of 16 coins to choose from. So it's this. But because he pulls it out, looks at it, puts it back in, when he goes to draw the second one, there's still 9 dimes and a total of 16 coins. So we can multiply these together and we get 81 out of 256. It would be a dependent event if he put his hand in, grabbed a coin, selected it, looked at it, and kept it. Then when we want to draw our second one, there would not be as many coins to choose from, so that would be a dependent event. And that's what we're talking about here. So he's getting a coin, he's not putting it back, he's hanging on to it and then going back to get a second one. So getting a 2 dimes, there's still 9 dimes out of 16. But because 1 dime is already used here, there's only 8 dimes left, and because 1 coin was already pulled out, there's only 15 coins to choose from. When we multiply that out, we get 3 tenths. I wonder how many people could sleep in those 3 tents out in the yard or a campground. Oh, sorry. Side note. Okay, so we're rolling 3 dice. So our dice is being rolled 3 times. So we want to get a multiple of 3. Then we get 1 dice that shows an even number. And then we want to get a dice that shows a 5. Well, multiples of 3 on a dice are only 3 and 6. So there's 2 options out of 6 possibilities. Even numbers, well, even would be a 2, a 4, or a 6. So that's 3 options out of 6 total possibilities. And then the last one we want to get is a 5. Well, there's only 1 5 out of the 6 options. So then we could multiply these together and we get 136. So down below here we have a game show host that draws chips out of a bag to determine the prizes that a contestant, I can talk here, will play for. He has 20 chips, 11 show computers, and 8 trips and 1 truck. So if the host draws the chips at random and does not replace them, what's the probability that they'll get a computer, then get a truck? So it's a certain order. Well, computers, we have 11 computers out of 20 chips. Or you could add your 11, your 1, and your 8 together to get your 20 also if you weren't told that there was a total of 20. Now, 1 chip has been drawn. We now want to get a truck. Well, how many trucks are still left? Well, there's only 1 because we picked a computer to begin with. But because we pulled out 1 chip already, there's only 19 chips left. So then we could multiply that together. So now, suppose we're not replacing and we want 2 trips. Same situation, we have 8 trips out of a total of 20, but 1 trip has already been selected here, so there's only 7 trips left out of a total of 19 possibilities, and we would get this. Okay, I know CDs are kind of old technology, but we'll just go with this one here. So these CDs, there's 12 CDs that are rock, 8 that are jazz, and 5 that are classical. He reaches into the box to select at random, and what's the probability of getting 1 jazz and then 2 rock? Well, to get 1 jazz, we had a total of 5 jazz. Well, let's see, how many total did we have? We had 12 rock, 8 jazz, and 5 classical. Oh, there's 25. So now we got to get a rock. Well, let's see, there's 12 rock, but because 1 jazz has been used, there's only 24 CDs left. Now we got to get a second rock. Well, 1 rock's been used, so there's only 11 left in there. 2 CDs have been pulled out, so there's only 23. So if we multiply these together, we get this. However, we have an issue here. Because it did not say jazz, then 2 rocks, it does not necessarily specify it has to be in this order. It's just saying you want a jazz and a couple of rocks. It could be a couple of rocks and then a jazz, or it could be a jazz in between your 2 rocks. And so if you list out all your different options to be able to figure out how many ways this could occur, you get 3 options. Now, this is also a combination situation. So you have a total of 3, and you're selecting one of them to be a jazz. So that's 3, choose 1. Or sometimes you'll see it written like this. But either way, if you would work that out, you would get 3. Now, we just did one of these. There's really 3 options. So we need to take 3 times what we just got right here to be able to get all the different situations occurring. So over here, you're asked to do a probability of 2 rocks and 2 classical. So get a rock is 12 out of 25. There's only 11 rock left, only 24 CDs left. Now we'll switch over to classical. There was a total of 5 classical, but now there's only going to be 23 CDs to choose from. And then for your last one, there's 4 classical with 22, and then we multiply. Now, once again, it did not specify it had to be 2 rock followed by or then 2 classical. So the order makes a difference here. If we switch the order, it's a totally different possibility here. So we just did this one, rock, rock, classic, classic. Or we could do this one here, where we switch the center to. Or we could go ahead and switch the last 2 and get this. Or we could basically have the complement, switch both the R's and C's around for each one of these. And so that gives us 6 options. Or a second way you could have thought about it is you were selecting 4 and you needed 2 of them to be the same. So you're choosing groups of 2 out of a group of 4. Whether you look at it this way for combinations or like this does not make a difference. If you did use your calculator and didn't list out your possibilities, you get 6. So we have to take our probability that we have and multiply it by the number of options or ways it could occur, and then we would get this.